Nasıl você?
Hello, am I audible? Am I audible? Can anyone please confirm?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am. My screen is visible, right?
Yes,
Yes,
ma'am.
ma'am.
Good evening,
Good
ma'am.
evening, ma'am. Good evening, everyone. I am Priya Katwal. I am doing PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur. Last week we discussed about fog computing and sensor cloud. Today we will discuss about smart cities. So, so what exactly is smart city? So, smart city is an urban system which yeah. So, smart city is an urban system which uses information and communication technology and makes the infrastructure more interactive, accessible, and efficient. So, basically, in your smart city, what happened is different components such as hospital, educational systems, banks, schools, these are able to interact with each other, right? So this can happen by deploying various kinds of sensors and actuators. So now what is the need of smart city? So because rapidly there is rapid growth in the urban population and due to which the natural resources are depleting very fast. Also there are various changes in environment and climate due to pollution. So in order to prevent all these things, there is a need of cities uh, which prevent this depletion of natural resources and provide better services to the individuals. So, for example, in beings, we have skeleton, skin, organ, brain, nerves, sensory organs, cognition. So, here in this table, an analogy is drawn between humans and smart cities. So, for example, humans have skeleton. Similar to that, smart cities have buildings, industries, peoples. Uh, Humans have skin. So, smart cities similarly have transportation, logistic, then organs in case of humans. So similarly smart cities have hospital, police, banks, schools, and different other components. Now if in human only skeleton, skin and organ are there, then the human cannot be considered as life, right? So in order to so, if there is no brain, nerve, sensory organ, and cognition in human, then it means that human is dead. Similar to that, in smart cities, we need some kind of communication between different components. So there should be some intelligence also. There should be some adaptive kind of things. So with the change in environment, the cities or the processes that are taking place, that should be adaptive. So similar to that, uh, in smart cities, like is in human, there should be some intelligence. So in human there is brain, so in smart cities also ubiquitously embedded intelligence should be there. Then nerves for communication, so similar to that, in smart cities there should be telecommunication networks for the communication of different components. After that, in humans, there are sensory organs which sense the environment. So, in smart cities, we have different kinds of sensors. Then, the cognition in humans, so we have softwares, various kinds of processes are there which will adapt to the environment. Now, the applications of smart. Wait, I'm getting call from the professor. Hello. Yes, sir. Yes, yes, sir. He said that. Yes, sir. He said that we have to manually add. Yes, sir. Okay. Okay, sir. Yes, sir. Okay, sir. Okay. Okay. Okay, sir. Yes, sir. I have NPTL now. After that, I'll do that. Yes, sir. Yes, sir. Yes, sir. I have already mailed you everything we need to just send. Okay, sir. Yes, sir. Yes, sir. Okay, sir. Yes, sir. Yes, sir. Yes, sir. Okay, sir. So, the applications of smart cities and smart homes. So, the first application is smart economy. So, to make the economy smart, to improve the competitiveness in your economy, there is a need of smart cities. After that, second one is smart governance. So, in case of smart governance, there should be an active participation from the citizens. There should be complete transparency between the citizens as well as the government. The so all the policies which are made by government should be transparent to the citizens. Then smart people, so smart peoples mean social and human capital should be increased in that case. Then smart mobility. after that, in smart environment, so smart environment means so the natural resources which are used by different people should be used in such a way that they should not get depleted. And then smart living means the quality of life of individual should get improved. So this will get improved if we are going to provide different facilities to the individuals or citizens. Then the smart economy, governance and people, we will discuss about that. So first one is smart economy. So in smart economy, in case of smart economy, the three main components are startup, indigenous diaspora and founders. So there should be complete interaction between these three components. Apart from that, these three components should be able to interact with the other components. So for example, your venture capital, academia, portal, public sector buyers, worldwide buyers, government agencies, global MNCs and international diaspora. Similar to smart economy, in case of smart governance, there are three main components, that is your government agencies, officials and citizens. So in case of smart governance, there should be complete interaction between these three components. Apart from that, these three components should be able to interact with the other components of the society. For example, banking, finance, reforms, safety, surveillance, management, public services, emergency services. So similar to this only, smart people have three main components, that is education, healthcare, population. There should be complete interaction between these components. Apart from that, they should be able to interact with other components. Next is smart mobility. So the main three components are cities, localities, population. So people move from one locality to other locality, one city to other cities. So in order to serve better mobility options, there should be complete interaction between these different components and with other components also. So likewise, we have smart environment and smart living. So the main three components of smart environment is locality, government agencies and population, and for smart living it is serving agencies, population and localities. Now the current focus areas of smart cities involve smart homes, smart parking lots, smart vehicles and smart health. So first one is smart homes. So smart homes consist of various kinds of components which are deployed, which helps in the health monitoring of the individuals, for the conservation of resources and security and safety. So considering first one, health monitoring. So in smart homes, different kinds of components are used. For example, your smartwatch and other different components which are able to monitor the vitals of individuals and also able to provide a remote monitoring of the health of the patients. Second one is conservation of resources. So for example, with the help, if you are in smart home, so basically if you are in a particular room, your lights will get automatically light up, and if you move out of that room, your light or switches will automatically get switched off. Security and safety involves, we have now different kinds of CCTV cameras which provides security to the individuals from the intruders. Second one is smart parking lots. So in smart parking lots, auto routing of vehicles to the empty slots are provided, auto charging for services are provided, detection of vacant slots in the parking lots are provided. So this can be done by deploying various kinds of sensors, for example camera sensor. So with the help of camera sensor, you can detect that which exact lot is free, and you can direct the vehicle to that particular lot. Next one is smart vehicles. So in smart vehicle, different kinds of assistantship is provided to drivers during the bad weather condition or low visibility. Also, if sometime assistantship is provided related to the traffic. So if a particular if a road is taken by a driver, some kind of assistantship can be provided, that this you may face traffic in that particular road. So some other alternate route can be provided to the driver. Then the detection of bad driving pattern or driving under the influence of substances can be detected in case of smart vehicles. After that, auto alert generation may be generated when there is an accident. Then your smart health, so low cost portable at home medical diagnosis kits are now there. Remote checkups and diagnosis are available. On body sensors for effortless and accurate health monitoring are present. Auto alert generation in case of emergency medical episodes are there. After that, pollution and calamity monitoring, you can use different kinds of sensors in order to predict that are whether there is any calamity or not. You can also use different kinds of sensors in order to predict the weather or monitor the weather. Alert generation in case of above threshold pollutants in air or water can be done. Then resource reallocation and rerouting of services in the event of calamities. The next one is smart energy. So in case of smart energy, smart metering system can be used. Smart energy allocation and distribution system should be there. Incorporation of traditional and renewable sources of energy in the smart grid. Then smart agriculture. So in case of this, we have already discussed many times. So for detecting the health of your plants, we can use different kinds of sensors. For checking whether any intruder wants to enter into your field, agricultural field, you can use different kinds of sensors. So this includes smart agriculture. So they have written automatic detection of plant water stress. So basically plant is getting proper amount of water or not. Monitoring of crop health status. Auto detection of crop infection. Auto application of fertilizers and pesticides can be done with the help of smart agriculture. Scheduling, harvesting and arranging proper transfer of harvest to warehouse or markets. So in order to ensure all these things, we can divide the whole process into four categories. So first one is data collection with the help of your mobile device, IoT devices, sensors. After that, whatever data you have collected, you have to transmit the data to the local storage place or to the server. So for that you need some networking topologies, and then data storage. So we need some local storage or data warehouses where you can store that particular data, and after that you need to process that data in order to draw some conclusion from that. Now the challenges, IoT challenges in smart city. So first one is security and privacy. So in case of smart cities, you are somehow using the private data of an individual, right? So that data may be exposed to some vulnerabilities or attacks, so that should be prevented. Next one is heterogeneity. So different kinds of sensors are deployed, different devices are deployed. So these devices or sensors belongs to different vendors. These devices are using different kinds of standards. So in order to make communication possible between these different kind of devices, it becomes difficult. So this is the second challenge. Yeah. Third one is reliability. So unreliable communication due to vehicle mobility is there. So we need to prevent that. Then large scale, since we have massive amount of devices deployed, right? So in order to manage that, it become difficult. Then legal and social aspects. Services based on user provided information may be subject to local and international laws. Individual and informed consent required for using humans as data sources. Then next one is big data. So the data generated by this massive devices is huge in amount. So managing that data, performing data cleaning, purification and analysis on that huge amount of data is a difficult task. Then sensor network. So to decide that which is appropriate sensor for your particular application, which kind of protocols you are going to use, how the communication should be made possible between these different devices. So deciding all those factors is a challenging task. Now data fusion. So as we have discussed that different sensors are going to generate large amount of data, right? So basically for a particular application only we are utilizing different kinds of sensors, or if we are using homogeneous sensor also, then sometimes we deploy multiple sensors at a same place, so for getting better results. So we need to fuse the data or aggregate the data from different sensors in order to reach to a particular decision. So this aggregation of data is called your data fusion. So what they have written is enormous volume of data is produced periodically in smart city environment. So challenges include making available and incoming large data precise and accurate. Now the quality of data precision and accuracy affects the quality of decision making in IoT enabled smart cities. Obviously, if the sensed data or the received data is inaccurate, then the decision will also be inaccurate, right? And if you are going to use only single sensor, you cannot say that whether the data which is sent by that particular sensor is accurate or not. So in that case we have to deploy multiple sensors. So data fusion enables optimum utilization of massive data gathered from multiple sources and across multiple platforms. Then next is multi-sensor data fusion. So it combines information from multiple sensor sources. It enhances the ability of decision making system to include a multitude of variables prior to arriving at a decision. After that, inferences drawn from multiple sensor data type is qualitatively superior to single sensor type data, because yeah, we have discussed that if that particular single sensor is not going to give you appropriate value, then how the decision will be appropriate. However, if you are using multiple sensors at a same time, then compared to that single sensor decision, that multiple decisions will be better. So information fusion generated from multiple heterogeneous sensors provide for better understanding of the operational surroundings. Now the challenges. First one is imperfection. So sometimes we are going to get inaccurate and uncertain WSN sensor data. Second one is ambiguity. Since you are using multiple sensors, so there might be a chance that there are some missing data, there are some outliers, then conflicts. So for example, you have used two same type of sensor and both the sensor are giving different values at the same location or same time. So there might be a chance that there is conflict between the data points. Then alignment. It arises when sensor data frames are converted into a singular frame prior to transmission. So basically we are getting the data from different sensors, we have to align them into to form a one singular frame. So how to align these different data. Then next one is trivial features. So processing of trivial data feature may bring down the accuracy of the whole system. After that, data fusion opportunities in IoT. So collective data is rich in information and generates better intelligence compared to data from single source. Optimal amalgamation of data is there in case of data fusion, and it enhances the collective information content obtained from multiple low power and low precision sensors. It also enables hiding of critical data sources and semantics. So these are the advantages of using of data fusion. Now the stages of data fusion. So exactly at which stage you are going to fuse. So first one is decision level. So basically you have collected the data from different sensors. You have run machine learning models on the data of different sensors separately. Now we have get different decisions. Now based on those decisions we are going to generate one single decision. Okay, so for example, if we have used temperature sensor, right, we have deployed four different DHT sensors which are giving different values. So okay, some are saying that the temperature is above 30, and only one is saying that the temperature is below 20. So the final decision will be made on the uh, dependent upon the maximum sensors which they have sent the data. So basically it will be above 30 only, so it is at the decision level. Second one is feature level. So fusion of information prior to decision making. So just before decision making, on the data which is received from different sensors, we are going to make some fusion. Next one is pixel level. So sometime what we do is, we collect the raw data from the sensors. After that we generate some images from that raw data in order to visualize that data. If we are going to fuse those images together, it is pixel level fusion. And if we are going to fuse only the raw data only, then it is signal level fusion. Then mathematical methods of data fusions. So first one is probability based. So you can use various methods such as Bayesian analysis, statistics, a recursive method in order to fuse your data. Then AI based methods such as ANN, machine learning, convolutional neural networks, you can use these methods in order to fuse your data. And then theory of evidence based, so belief functions, transferable belief models, you can use these different kinds of method in order to fuse your data. So this is the link I have given, you can go through that if you want to know more, if you want to know more about these different kind of data fusion methods. Now AI in IoT decision making. So if we are going to take the decision without involving AI, so the decision is not that much accurate or appropriate. So there is a need of AI which make your decision highly accurate. So this figure is just saying that only. So, yeah. So this figure is showing the data fusion for autonomous vehicle. So basically this is a vehicle which have different kinds of sensors deployed over it. For example, RGB camera sensor, lidar sensor, ultrasonic sensors to detect the obstructions which are present on the road. So depending upon the data which is gathered by these three different sensors, it is decided whether there is an obstruction or not. Now next topic is next topic is okay, wait. Next is smart parking. So smart parking results in shorten the parking search time for drivers. It reduces the traffic congestion, reduces pollution by keeping unnecessarily lingering vehicles off the road. Yes. Are you trying to say something? Then smart parking reduces the fuel consumption and cost and increases the urban mobility. It shorter the parking search time results in more park time and hence more revenue. Now for smart parking, information collection can be done with the help of sensors, parking meters, sensor networks and crowd sensing. Then your system deployment is done by deploying various softwares, information management system, e-parking, guidance and data analytics. Then third one is service dissemination. So for service dissemination, different kinds of services, for example dynamic pricing, different strategies, infrastructure based information is transferred to the driver, then infrastructure free information, then parking choice, then the vehicular activity. So all this information should be disseminated to the drivers. After that, this sensing can be of two types, stationary and mobile. So for stationary, you have to deploy large number of sensors which will detect the presence or absence of vehicles in that particular place. And if it is mobile, you need to deploy fewer sensor as compared to stationary, and it collects the information along with the route of the vehicle. Now energy management in smart cities. So these are the different energy efficient solutions. For example, you can use lightweight protocols. So researchers have developed different kinds of lightweight protocols which results in preserving the energy. Second one is scheduling optimization is one of the solution. Then predictive model for energy consumption is there. After that, cloud based approaches are there. Low power transceivers you can use, cognition management framework. So basically these are only few solutions. There are various other solutions which are proposed by different researchers. After that, energy harvesting solution. So ambient energy harvesting can be done. So for that you can use RF sources, wind, sun, heat, vibration. So basically all the for from the natural resources you can get the energy and harvest that. So energy harvesting solution is dedicated energy. So in case of that, energy sources intentionally deployed near to the IoT sources, amount of energy harvesting depend upon the sensitivity of the harvesting circuit, distance between the device and the source, and the environment where you have deployed that. Then smart home. So basically we have discussed about till now smart cities. Inside smart cities we have discussed your smart in smart cities we have discussed about smart parkings. Now after that we will discuss about smart homes. So smart home infrastructure consists of intelligent network device infrastructure. So there should be seamless integration of various devices using wired and wireless technologies. So can anyone tell me that we have already discussed one protocol which is only developed for smart homes. Can anyone tell me the name? Anyone? IoT protocol which was developed for smart homes. Check your notes and tell me. So, Z-Wave was developed for smart homes for the communication of different devices which are deployed in your smart home. Z-Wave was developed. Wi-Fi. Yeah, but Wi-Fi was not developed only for your for the communication of devices which are deployed in your smart homes only, right? So Z-Wave was the protocol which was only developed for your smart homes devices. So it allows ease of use for household system, creates a highly personalized and safe home space. So corporation which are indulged in smart home systems include GE, Cisco, Google, Microsoft, and there are various others. It provides a productive and cost efficient environment, maximizes the effectiveness of occupants. So you can go through these. We have already discussed this kind of thing in the previous lectures also. Yeah, now the elements of home area network. So first one is element, then standard, architecture and initiative. Network contained within a home is called your home area network. It enables remote access and control of devices and systems. It provides amalgamation of various systems within home such as security system, home automation system, personal media and communication. So basically home area networks means the network which is formed by different devices which are deployed in your home, whether it is a security system, whether it is automation system. For example, you are going into your room, your lights will light up, and if you are going out of your rooms, they automatically get switched off. Or personal media system or communication, anything. Now the elements. So first one is your internet protocol, then wired home area network and wireless home area network. So internet protocol, so multi-protocol gateway bridges the non-IP network to the IP network. Bridging between new technologies is limited. For new technologies or networks, a new mapping is required for bridging to perform satisfactorily. Then wired HN, so easy integration with pre-existing house infrastructure is there. It is low cost and can use power line, coaxial cable, telephone lines in order to establish the connection. After that, wireless home area network can use popular Wi-Fi, Zigbee and even new standards such as 6LoWPAN. Wireless make implementation easy. Now again, so networking technologies can be wired or wireless. If it is wired, your electric lines, telephone lines, optical fibers can be used, and if it is wireless, it can be either battery operated or battery free. If it is battery operated, then there is no energy harvesting kind of thing. You have to deploy battery So example are Z-Wave, Wi-Fi, 6LoWPAN, Zigbee, and if it is battery free, it is going to use natural resources. So example is Enocean. Then after that, different standard home area network standards. So these are the different standards. First one is UPnP, DLNA, Connex, Loanworks, Zigbee, Extend. So UPnP is an application layer technology, mainly web based. So for all these standards you have to go through the properties and you have to learn these properties. Questions can be asked from these different standards. So TCP IP protocol stack provides support for lower layers and enables seamless integration of various technologies. It provides transparent networking with support for zero configuration networking and automatic discovery of devices. Second one is DLNA, that is Digital Living Network Alliance. So it is a trade organization which is created by Sony, Intel and Microsoft. It connects cable-based network with wireless networks for increased sharing of media, control and access. It domestically shares network media resources. The next one is Connex. It is an open important standard for home and building network. It utilizes the full range of home communication infrastructure, power line, coaxial cable, twisted pair, RF, etc. It must be set up and configured by software before its proper usage. Then the next one is uh, local operational networks. So every device includes a neuron chip, a transceiver and application electronics. Neuron chip is a system on chip with multiple microprocessor, RAM, ROM and IO interface ports. It splits device group into intelligent element which can communicate through physical communication medium. Then Zigbee. Zigbee we have already discussed. You can go through the properties. Then next one is Extend. It enables remote control of compliant transmitter and receivers over power line and electrical wiring present in the house. Now the architecture. So basically we have two different kind of architecture for home area network. First one is Domonet and second one is Zini. So yeah, for this you have to go through. For if you get any question, you have to go through their properties. You can read these one by one from the slides. It's already there in the NPTEL website also. So now the two initiatives of home area networks are Project Hydra and Amigo. So Project Hydra is a middleware for embedded intelligent system. It connects software oriented architecture network. Connected devices may have limited resources, low processing power and memory or energy consumption. Each device has an embedded Hydra client which acts as a proxy between the device and the middleware. However, Amigo, so the aim is to get ambient intelligent system for the networked home systems. The features are user-friendly interface, interoperability and automatic discovery of devices and services is provided by Amigo. Now next one is connected vehicles. So connected vehicles means the vehicles which are equipped with different kinds of sensors. These vehicles are able to interact with each other with the help of different networking protocols. These are capable of communicating with the other devices within the vehicle, communicating with other similar vehicle, and communicating with the infrastructure, fixed infrastructure. Now the challenges which are involved in connected vehicles are security, privacy, scalability, reliability, quality of service, and lack of global standards. So basically this figure is showing that an IoT, there is an IoT, then subset of IoT is vehicular cloud, and then inside vehicular cloud it's connected vehicles. Now vehicle to everything paradigm. So vehicle to everything paradigm means that vehicle should be able to interact or communicate with everything else. For example, the humans, the pedestrians, vehicles which are running on the roads or which are standing also, the mobile towers, etc. So basically the main components of future intelligent transportation system is this vehicle to everything. It enables vehicle to wirelessly shares a diverse range of information. Information sharing may be with other vehicle, pedestrian or fixed infrastructure, that can be your mobile towers, parking meters, etc. It allows for traffic management, ensuring on-road and off-road safety, mobility for traveling. It follows a distributed architecture where contents are widely distributed over the network. It is not restricted to single source of information providers. It is designed mainly for highly mobile environment, can share information to nodes in vicinity as well as remotely located, has greatly enhanced travel efficiency as well as safety. The network is mainly used as a tool for sharing and disseminating information. So basically these vehicles should be able to communicate with the vehicles which are closer to its proximity, or should be able to communicate with the nodes which are remotely present. So these should be like that, they should be able to transmit the information in such a manner that the information should be disseminated to the uh, fixed infrastructure which are not in the proximity of that particular vehicle. Now the failures of TCP/IP in vehicular to everything paradigm. So this TCP/IP model, which is used in normal networking, cannot be used in vehicle to everything paradigm, because TCP/IP model was designed mainly for handling information exchange between a single pair of entities. However, in case of your vehicle to everything paradigm, your single vehicle can communicate with different vehicles at the same time. Information exchange is dependent on the location of data in case of your TCP/IP model. However, in case of vehicle to everything, the vehicles are mobile, so this information of exchange cannot dependent upon the location of data, so you cannot use TCP/IP model in such case. Can only identify the addresses of endpoint, which alone is not useful for content distribution. It increases the number of wireless devices, restrict the mobility of nodes. So basically your TCP/IP restrict the mobility of nodes. However, in V2X you need some protocol or some model which uh, enables this mobility of nodes, because vehicles are moving continuously. So in order to achieve this or provide some basic standard architecture for your vehicle to everything. Content centric networking is used, so it is derived from information centric networking architecture. It focuses more on data than its actual location. So basically, this data is stored in an hierarchical manner. So basically, whenever you want to fetch in data, you don't need to access the address of that particular data. So hierarchical name data is stored. Hierarchical data is transmitted directly instead of being a part of conversation, enables scalable and efficient data dissemination. In-network caching allows low data traffic and works well in highly mobile environment. So the routing protocols are similar to MANETs only, that is mobile ad hoc networks. High throughput achievable in mobile network and guaranteed low latency in mobile environment. So these are the features of VNet. So first one is highly dynamic topology, because your vehicles are continuously moving, so topology is highly dynamic. Second one is high transmission and computation capability should be there. So vehicle stored energy sources and computational power do not restrict the capabilities. Then unstable connectivities. So link durations are short due to highly dynamic natures of VNets, due to which the connectivity is unstable. And then large scale, so can be easily scaled up to include all the vehicles on the road. Next one is predictable mobility pattern. So vehicular restriction within road make mobility patterns predictable. Now the application, first one is safety, then efficiency, commercial and comfort. So in case of safety, emergency braking, lane change warning, collision avoidance, hazard notification, you can use vehicular ad hoc network in this case. Then for efficiency, for cognition management, electronic toll collection, parking availability, you can use VNets. Then for internet access and multimedia stream, you can use VNets. Then for weather information, autonomous driving, journey time estimation, VNets can be used. Now routing in case of VNets. So forwarding and routing based on name of content, not locations, because TCP/IP model is not used. However, your CCN is used. Content centric networking is used. Individual content name prefixes are advertised by the router across the network. This helps to build a forwarding information base for each router. The name of content remains same and unique globally. No issues of IP address management is required in this case, and communication does not depend upon the speed or direction of the nodes. Then the scalability. So an in-network caching mechanism at each router is required. Uniquely identifiable data chunks are stored in content store, which act as a cache. Subsequent request for stored data chunk can be made to CS. The naming system for CS enables the data to be used multiple times, unlike normal IP based router. So it reduced network load during the increased network size as a result of caching mechanism. Now in vehicle network architecture. So there is body and brain architecture is used. So basically it is a three layered architecture which consists of body, nervous system, brain. So body means sense and execution, so which consists of different kinds of sensors. After that network and after that nervous system, which will consist of network and transmission. So various kind of networking protocols are deployed in this layer. Then third one is brain, where some analytics is performed. So various machine learning models are deployed which will help in taking the decision. So these are the different layers. So first one is sense and execution layer. So various sensors, actuators, radio are deployed. For example, lidar, radar, proximity sensors, steering, brakes, lights, these are the actuators. Then a radio, in case of radio, vehicular to everything. Then for a network and transmission layer, so it is the intermediate layer between your sensors and the decision layer. So it consists of different kinds of protocols which help in the communication of these different protocol. And decision layer consists of administrative node and supervisor nodes which helps in the transmission of information as well as commands, and also helps in taking the various kinds of decisions by performing analytics over the data. Now, so phases of ICB development. So first phase is infotainment service with remote information processing. It is based on 2G or 3G. Second phase is intelligent transportation service, which is based on 4G LTE. And third phase is vehicle connected to the cloud. Now this is a scenario where crash. So for example, so in first case, uh, this intelligent connected vehicles means basically a vehicle have different sensors, and these vehicles are capable of taking decisions also. So depending so here in this scenario, depending upon the speed, direction and braking system, the crash can be predicted. So alerts are generated, and warnings are sent to the drivers. So for example, your speed is high as compared to the threshold value, so you should low down your speed in order to prevent the crash. Okay, so in this case also, so for example, here is a blind spot. So in order to prevent crash, intelligent connected vehicles can be used which can predict that okay, in the blind spot there can be any kind of vehicles or pedestrian who can come across. Now the domains of VNets. So first one is in vehicle, ad hoc and infrastructure. So in vehicle domains composed of one or more on-road board units, on-board units, that is OBUs. Additional presence of advanced driver assistance systems such as cameras, proximity sensor, engine sensor, radars, actuators are there. And communication is mainly through controller area network, vehicular power line network and Ethernet. The next one is ad hoc domain. So it composed of vehicles and roadside units. The vehicles are mobiles. The roadside units are static, and communication mode may be either vehicle to vehicle or vehicle to infrastructure. Then third one is infrastructure domain. Infrastructure domains mean RSU, that is roadside units connected to the internet by means of gateways. In presence of RSU, the vehicle may communicate to the internet by vehicle to infrastructure interfaces. In the absence of RSU, the vehicle may communicate with each other or internet through cellular networks such as 3G, 4G or LTE. Now the advantages. So it increased traffic safety, increased driver safety, optimized time of travel, efficiency of fuel consumption, secure travel, easier drive in low visibility or unfavorable weather condition. And then the disadvantages are violation of privacy, loss of data control, collection of personal data, second use of data, data used by unauthorized entities, tracking of movement, localization of position. Now we have discussed different concepts related to your vehicle. First one is Internet of Vehicle, second is vehicular ad hoc network, connected vehicle and intelligent vehicle. So anyone can please tell me the difference? IOV, VNet, connected vehicles and intelligent vehicles. Anyone? We have already discussed all these four concepts. Now you just have to tell me the difference. First one is Internet of Vehicle, second is VNet, third is your connected vehicle, fourth is your intelligent vehicle.
Madam, questions not seen.
What? Can you please repeat?
Questions are not displayed on the screen, ma'am.
Yeah, I'm not showing the question, I'm just asking you that we have discussed four different technologies, right? First one is IOV, Internet of Vehicle, second is VNet, Vehicular Ad Hoc Network, third one is Connected Vehicle, and fourth one is Intelligent Vehicle. So I'm just asking you the difference between all those four technologies. Anyone?
In case of intelligent vehicle, if there is any blind spot that can be identified by the intelligent vehicle.
Basically there is some intelligence in your vehicle, so it is able to predict something, it is able to take decision, right? So this is your intelligent vehicle. Next, connected vehicle.
So in connected vehicle, we can establish a communication between the vehicles which are connected with the help of the network.
Right. So the main difference between the intelligent vehicle and connected vehicle is that your basically connected vehicles means they have only sensors, they are only going to collect the information, they can sense the environment, right? So they don't have any capability to process that information or take any decision, right? However, your intelligent vehicle have sensors, so they can be your connected vehicle, but apart from that they have the capability of decision taking. Okay, so two are clear. Now IOV and VANETs.
In case of vehicular VANET, vehicular radar network, the vehicle will have uh, can do the communication with the pedestrians, other vehicles, and also with the mobile towers. We can establish a
Okay.
connection in case of VANET, that is vehicular radar networks.
Okay. And IOV. Internet of Vehicle. Okay, so basically this table is showing the difference or the main focus area basically. So first one is IOV. So it is the integration of vehicle into the Internet of Things ecosystem. So basically the main focus is integration of vehicles with IoT. Second one is VANET. So it is providing a communication infrastructure with the help of which these vehicles can interact with each other. These vehicles can interact with other components, for example pedestrian, for example other Internet of Things, or everything. Third one is connected vehicle. So basically vehicle equipped with sensors which can communicate with each other. Fourth one is intelligent vehicle. Intelligent vehicle equipped with sensors and they are capable of taking decision also. So clear? Yeah. Now questions, but before taking questions let's take a break of 5 minutes and after that we'll start. First question is fill in the blank. Facilities that need to be provided in smart parking lots include blank. Options are identification of empty slots in parking slot, automatic routing of vehicles in vacant slot, C is automatic charging for services rendered, all of these.
It's option D, all of this.
All of these. Okay, anyone else?
Yes, ma'am, all of these.
Yes, so it is all of these. Next question is in near future, auto alert generation in case of sudden heart attack leading to emergency medical condition is supposed to be handled by smart health, true or false?
True.
Option A, true.
Okay, anyone else? Anyone else?
True.
True. Okay. Yes, so this statement is true. Next question is during an event of disaster, the resource reallocation and service rerouting can be handled by which of the following method? Options are energy monitoring, traffic monitoring, calamity monitoring, health monitoring.
It's option C, calamity monitoring.
Okay, anyone else? Anyone else? During an event of disaster, the resource reallocation and service rerouting can be handled by which of the following method? Energy monitoring, traffic monitoring, calamity monitoring, health monitoring. Anyone?
Traffic monitoring.
Which one? Traffic? It is calamity monitoring. Which of the following challenges can be experienced due to the periodic generation of large volume of data in smart city? Options are making data volume precise and accurate, provisioning quality of service, third one is proper resource management, and none of these.
It's option A, making data volume precise and accurate.
Yes, ma'am, option A.
Okay, anyone else? Anyone? So correct option is making data volume precise and accurate. Next question is fill in the blank. Blank enables optimal usage of huge data generated from different sources and across different platforms. Options are data storage, data cleaning, data fusion, none of
It's
these.
option C, data fusion.
It's data fusion. Next one is, which of the following is included in mathematical model that is used for performing data fusion? Options are convolutional neural network, statistical model, belief functions, all of these.
It's option D, all of this.
Question, okay. Anyone else?
Yes, ma'am. Option D.
Yeah, it's option D. Next question is, which of the following statements are true about the different components present in smart home? Statement 1 is sensor networks and communication network infrastructure. Statement 2 is intelligent control and management. Third statement is manual instead of automatic access of devices. So, uh, okay. Option A is statement 1 and 2, B is statement 1 and 3, C is 2 and 3, D is 1, 2,
It's
3.
option A, statement 1 and 2.
Anyone else?
Yes, ma'am. Option A.
Right, option A is correct because in case of smart home there is no manual, right? Next one is, which of the following are included in home area network standards? Statement 1 is UPnP and LONWorks. Statement 2 is ZigBee and Extend. Statement 3 is DLNA and ZigBee. Options are 1 is 1 and 2, B is 2 and 3, C is 1 and 3, D is 1, 2, 3.
It's D, 1, 2, 3.
1, 2, 3. Right. So all these are, that is UPnP, Onwork, ZigBee, Extend, DLNA. These are the standards of home area network. Next question is blank. Blank provisions amalgamation of different features at home, including home automation systems, personal media, security system, etc. Options are local area network, personal area network, metropolitan area network, home area
It's
network.
option D, home area network.
Okay, anyone else?
Yes.
Right, it is home area network. So, home area network provisions amalgamation of different features at home, including home automation system, personal media, security system, etc. Next question is fill in the blank. In vehicle to human, human to vehicle interaction, the human communicating with vehicle blank. Options are is present in another vehicle, is present in same vehicle, is present outside the vehicle on the roadside, all of these. Anyone?
It's option C, vehicle to human and human to vehicle. Option C.
Anyone else? Yes, it's option C. So basically, vehicle in a human to vehicle or vehicle to human interaction, human communicating with the vehicle is present outside the vehicle on the roadside. Next question is, information centric networks are derived from content centric network architecture. True or false?
It's false. That is CCN is derived from ICN.
Right. So this is false. Next question is, which of the following statement is true about vehicular ad hoc network? Options are: routing protocol of MANET is derived from VANET. B is high latency is achieved in mobile environment. C is does not have wireless access in vehicular environment. None of these.
It's option
Anyone?
C, does not have wireless access.
Okay. Anyone else? It's none of these. So, in vehicular ad hoc network, routing protocol VANET is derived. Okay, what was the question? Does not have. Okay, yeah, routing protocol of VANETs are derived from MANETs. High throughput is achieved in mobile environment and it is based on wireless access in vehicular environment. Next question is, which of the following is considered in intelligent connected vehicles? Options are intelligent transportation, communication channels, pedestrian, all of these.
So option D, all of this.
Anyone else? Anyone? Right, it's all of these. Next question is, dedicated short range communication standards developed by Society of Automotive Engineers are SAE Z, Z2735 and J2945. True or false?
True.
True. Okay, anyone else? Yes, it is true. Next question is, what are the disadvantages of V2X communication? A is increased traffic safety, B is efficient use of fuel, C is tracking of movement, D is none of these.
It's option C, tracking of movement.
Tracking of movement, okay.
Yes,
Anyone
ma'am.
else?
Tracking of movement.
Right, tracking of movement is a disadvantage of V2X communication. So it results in the violation of privacy. Next one is fill in the blank. In LearnWorks, each neuron chip has blank memory type. Options are ROM and RAM and EEPROM. C is ROM and EEPROM. D is ROM, RAM and EEPROM.
It's option D.
D. Okay, anyone else? Yes, it's D. So all these GROM, RAM, and EPROM are there in neuron chip. Next question is V2X follows centralized architecture. True or false?
True, ma'am.
True. So, okay, how?
It's false. V2X follows centralized architecture.
Right, it's false. Basically, V2X follows distributed architecture. So, everyone in the network are able to communicate, interact, they have their own control. So, there is no particular centralized entity which is controlling the vehicles. Next question is which of the following is not true about content centric networking? Options are A focuses more on actual location than data, B is hierarchical data is transmitted directly instead of being part of a conversation, C enables scalable and efficient data dissemination, D derived from information centric networking architecture.
It's option A. It
Option A.
focuses more.
Option
Option A.
more. Option A.
Not true.
Okay, not true. Huh. So question is not true. So basically A is false because A is focuses on actual location. Whether in content centric network it focuses on data rather than its location. So A is false. Next question is in VANET, link durations are long and easily scaled up to include all vehicles on the road. True or false? Anyone? In VANET, link durations are long and easily scaled up to include all the vehicles on road. True or false? In the features we have discussed this thing. No? This statement is false because the link durations in case of VANETs are very small because vehicles are mobile. Next question is which of the following is not true about ad hoc domain? Options are A is composed of vehicles that is OVUs and roadside units. B is vehicle and roadside units are mobile. C is communication take place through DSRC stack. D is communication mode may be either V2V or V2I. Anyone?
Option D.
Option D. D. Okay. Anyone else? So correct option for this is B because roadside units are not mobiles, these are static. Vehicles are mobile. Next question is in infrastructure domain RSUs are connected to internet by means of blank. Options are V2I interface, cellular network, V2V interface, gateway.
It's option D, gateway.
It's option D,
I think
gateway.
option A.
I think option A. Option A, B. Okay, anyone else?
Gateway.
It is D. Gateway. D. D. Next question is, which of the following is the draft standard for wireless access in vehicular environment? Options are A is IEEE PI 609.0, IEEE PI 609.1, IEEE PI 609.2, and D is version 3, PI 609 version 3. Anyone? No? Correct option for this is A, that is IEEE PI 609.0. Next question is, inferences drawn from multiple sensor data is qualitatively superior to single sensor type data. True or false?
It's option A, true.
It's option A, true. True. Okay. Anyone else?
SPM true.
SPAM true. True. Right. So correct option for this is true. I have already shared the link. You can access the PDF from the link. I have already uploaded the PDF in the same link. Next question is, which of the following statements are not correct regarding data fusion? Options are rich in information, generate better intelligence, optimal amalgamation of data, expose critical data sources, and semantics. Anyone? Correct option for this is D, that is expose critical data sources and semantics. Next question is, what happens at signal level of data fusion? Options are A is fusion of information at imaging device level itself. B is fusion of information at the sensor node with the local network itself. C is fusion of information prior to decision making. D is ensemble of decisions. Anyone? one?
It's option B, fusion of information at the sensor node.
Okay. Anyone else? It's B. So signal level mean fusion of information at the sensor node within the local network itself. The next question is, which of the following is not a functional layer of smart parking? Options are: A is information collection, B is information fusion, C is system deployment, D is service
It's
dissemination.
option B, information fusion.
Right. We have three layers, that is your information collection layer, system deployment layer, and service dissemination layer. So B is correct option. Next question is, fill in the blank. Solution related to smart cities should have blank. Options are: cognitive management framework, low power transceiver, C is predictive model for energy consumption, all of the above.
It's option D, all of the above.
All of the above. Okay. Anyone else? Yes, it's all of the above. Next question is, in UPnP, device search and advertisements are blank through HTTP over UDP over port 1900. Options are multicast, unicast, broadcast, stored.
It's option A, multicast.
Multicast. Okay, anyone else? Yes, it's multicast. Next question is, UPnP is blank layer technology. Options are data link layer, application layer, network layer, transport layer.
It is option B, application layer.
Application layer. Okay, anyone else? Right, it's application layer technology. Okay, so which week assignments did you get this week? Anyone? Week 10 or 11?
Week 10, the due date is tomorrow for week 10.
Okay. Next question is, in LearnWorks, every device includes a neuron chip.
It's
True
option
or
A, true.
false? True. Okay, anyone else?
True.
True, ma'am.
True. Right, this statement is true. Next question is, a smart city blank. Options are: is a urban system, uses ICT, makes infrastructure more reliable,
It's
all of
option
these.
D, all of this.
Yes.
Right. It's D, all of these. So basically, a smart city is a urban system which uses ICT and makes infrastructure more reliable. Next question is collective data is more intelligent than single sources.
True.
True or false? Right. So this statement is true. Next question is which of the following is one of the challenge of data fusion? Options are imperfection, conflict, ambiguity, all
So
of
all
the
of
above.
the above.
All of the
All of the above.
Anyone else?
all of the above.
Right, all of the above. So all the three are the challenges of data fusion. Next question is which of the following are the challenges of IoT in smart cities? Options are security and reliability, small scale, homogeneity, none of these.
First one.
Security and reliability. Okay, anyone else?
The question is not clear. Which of the
The
following
question
challenges
is
are
not
the
clear. Which
challenges?
of the following
Yeah.
challenges are the challenges?
So it should be like which of the following are the challenges of IoT in smart cities?
Next option is security and reliability.
Next option is
Right.
security and reliability.
Security and reliability are the challenges of your smart cities. Next question is fill in the blank. Blank combines information from multiple sensors. Options are data storage, data cleaning, data
It's data
fusion, none
Data
of
fusion.
these.
fusion, ma'am.
Data fusion.
Right, data fusion is correct option. Next question is which of the following are non-functional layers in smart parking? Options are information collection, system deployment, service dissemination, all of these. Anyone? All of these is the correct. We just discussed similar kind of question. So what I realized is in every run you will get similar kind of question. Only the language is different or something like that. So did you find any question similar to your this week assignment
Yes,
till
but
now?
this question is repeated but different way. This question is repeated but different way.
Okay, yeah, this is what I found also because we have three runs questions. I have 45 questions in this slide, right? So, three run questions I have, and all the questions are somehow related to each other. Next question is which of the following statements are true about different components present in smart home? Statement 1 is sensor networks and communication network infrastructure. Statement 2 is intelligent control and management. 3 is manual instead of
First
automatic
and
access of devices.
first one.
So option first one, right? This is repeated question only. So first one is correct. Next question is which of the following are included in service dissemination of smart parking? Statement 1 is dynamic pricing. Statement 2 is infrastructure free and infrastructure based information. Third is parking choice. So option A is 1 and 2, B is 2 and 3, C is 1 and 3, D is
It's
1, 2, 3.
last D. Statement 1, 2, and 3.
Last D. Statement 1, 2 and
Right, statement 1, 2 and 3. So basically for service dissemination, dynamic pricing, infrastructure free information, infrastructure based information and parking choice, all these information should be provided. Next question is fill in the blank. Blank is a network contained within a home. Options are local area network, home area network, personal area network,
Local
metropolitan
area
area
network.
network.
Home area network.
Local area network. Home area network. It is network
It is
contained
home
within a
area
home.
network. Home area
It
network.
is home area network. Home area network. Right. Home area network is correct option. Next question is fill in the blank. In vehicle to human and human to vehicle
Option C.
interaction, the human communicate. Yeah, repeated question only. Option C is correct. So it is present outside the vehicle of the roadside. Next question is wired home area network provides easy integration with pre-existing home or house infrastructure.
True.
True or false?
True.
True. Yes, this statement is true. Basically, in case of wired home area network, either coaxial cable, optical fibers, or telephone lines are used for the communication. Next question is which of the following statement is true about conics? So first is utilizes only short range in home. Second is can be used before configuration. C is does not have standards for building network. None of these.
None of these.
None of these. None of these. Okay. Anyone else? Yeah, so none of these is correct. Next question is which of the following is the reason for failure of TCP/IP model in V2X? Options are A is TCP/IP handles information exchange between multiple pair of entities. B is the increase in number of wireless devices restricts the mobility. C is TCP/IP can identify the addresses of the endpoint. D is information exchange does not depend on the location of the data.
Second one.
Anyone?
Second one.
Which one? Second, the increase in the number of wireless devices restricts the mobility. Anyone else? Yes, B is correct. Next question is CCN is derived from ICN
True.
architecture. True or false? True. True, right. So we have discussed similar questions. So that question was ICN was derived from CCN. So this statement is true. Next question is what are the disadvantages of V2X communication? Options are increased traffic safety, tracking of movement, efficient use of fuel, none of these.
Tracking of movement.
Tracking of movement. Tracking of movement. Yes. Tracking of movement is the disadvantage of V2X. So these were the questions. So I'm again I have uh, I have given the link in the chat box. You can access the PDF from this Google Drive link. And if you have any question, you can ask. If not, then I am terminating the session. Okay. Okay, then thank you.